Actually, no, it was the name of the race. Actually, no. Dude, people here before. I don't even. Really, buddy? Do you want to go?
I'm trying to do math.
Demon magic.
Yeah.
Well, good afternoon. I hope everybody's doing well this afternoon. That was interesting for me to watch. Let's see what kind of success we had. So you see the note that you should not have used your cheat sheet. And we're going to have a little conversation about cheat sheet after we're done getting answers. But let's work on being successful with these questions. So, number one, what did you get for the values of x and y? I've got student number 4, student number 5, and student number 8.
For x I got 6 and for y I got 4.
For x I got 6, but I didn't solve.
Okay, student number 8.
X equals 6 and y is 4.
Y equals what?
No, x is
X is 6 and y is 4. Number 2, find the measures of angle A and the measure of angle C. I've got student 11, 6, and 2. Student number 11. Student number 6. Student number 2. Measure of angle A is 45 degrees, and the measure of angle C is 72 degrees. And for number 3, find me the measure of arc BC. I've got student number 1, student number 20, and student number 12. Student number 1.
Arc BC equals 52.
Student number 20. Student number 12.
Measurement of arc BC is 52 degrees.
52 degrees. So, the hiccup for most of you was not having the crutch of the cheat sheet. So it's not that you don't know how to do these, how to work through problems. It's not that you don't know how to use the tools, but you didn't remember the tools. You can't use the tools if you don't remember them. So we'll continue that conversation after we explore how. So give me a thumbs up if you got number 1 correct. 1, 2, 3, 4, 5, 6, 7. Good. Kayla, what's the first thing you did to work through number 1?
I tried to get x.
And how'd you do that?
I did the 9 times 4 equals the 6 times x.
Very good. 9 times 4 must equal 6 times x. There's a theorem. I don't know what the name of the theorem is. It doesn't really matter. But what the theorem says is if you have 2 lines intersecting, 2 chords intersecting in a circle, that the product of their segments will equal each other. So we solve this and we get x equals 6. So now this value is 6 right here. Catalina, did you take the same approach? What did you do to get y?
I saw that 8 was a tangent line, and so I did 8 squared equals y times the product of the line inside, which is y plus 12.
Very good. So, the square of the tangent will equal the product of the external segment and the whole secant. Solve that equation and you get y. So this comes out to 64, this comes out to y squared plus 12y. And yeah, you got to do a little work, but it actually factors really easily. and you get one positive answer and one negative answer. The negative one is disregarded. The positive answer is 4. Any comments or questions? So it is my strong belief that there's not one student in this room who can't actually do that. But there are many students in the room who couldn't remember the relationships involved. So that's the hurdle we have to get over. You're going to see that it's even more profound in number 2. Give me a thumbs up if you got number 2 correct. Good. Zabari, what is the first thing you did in number 2, if you can think back?
First, I took a lot of things about if the triangles are similar, and so I said that the triangles are similar, and so I made angle D equal to angle C. So I did 3x minus 24 equals 2x.
Okay, so let's set that up. We're going to set up 2x plus 8 equals 3x minus 24. But whether or not these are similar triangles, you kind of got circular logic here, because you're saying that they're circular because they have two congruent angles, but we don't have the congruent angles, so you kind of have circular logic. You're using a concept to find the concept that you need to use the concept. So could someone tell us the real reason why this is true? Why is that true? Because he's right, but he has the wrong support for it. Brian?
Because both angles intersect the same arc.
That's right. If you have two inscribed angles that intercept the same arc, they are congruent to each other. So, angle angle BCA and angle BDA both intercept arc AB. Two inscribed angles intercepting the same arc are congruent to each other. So you can solve this equation to get the value of x, and then plug that value back in, and you will get the measure of angle C, which comes out to be this right here. How do you get angle A? Michaela?
Same way.
Same exact way. Look at the other direction. You've got this angle here and this angle here, both intercepting this arc right here. Which means this angle is congruent to that one. There was actually no work involved in finding that, except remembering. Any comments, questions on numbers 1 or numbers 2? Numbers 1 or 2. Any questions? Any comments, concerns, observations? All right, quick look at number 3, which was the easiest one of them all. I had a number of students who asked me if this was a right triangle. My question is, should you be asking me? What do you have to say, Sebastian?
No, because since the triangle has the diameter inside of it, technically already because the triangle has the diameters on its sides, it isn't a right triangle.
Yeah, it is a right triangle. Of course it is. Because we have a theorem that says that if a triangle is inscribed in a circle and the hypotenuse is the diameter, then it must be a right triangle. I don't know what the name of that is. Something like the inscribed right triangle theorem or something like that. But it doesn't matter. It doesn't matter what it's called, because what matters is the idea. If you see a diameter and that's the hypotenuse of the triangle, then yes, this is a right angle. By the triangle sum theorem, you can get that angle A is 26 degrees. And then understanding that the relationship between an inscribed angle and its intercepted arc. An inscribed angle will be half of the intercepted arc, or conversely, the intercepted arc will be double the angle. So this will be 52. Any questions about that?
No, I just wanted to say that I did it a different way.
Go.
I did 64 times 2 and I got the arc AC.
Beautiful.
And then since you know because of that theorem that AB is a diameter, you know that's 180.
Very good.
60 minus 180 minus 128 equals 52.
Beautiful. Let me write that in. So this is a diameter, which means this arc over here, this AB is 180 degrees, and you did double 64, so that gives us 128 degrees over here for arc AC. Measure of a arc BC must be the sum of those two subtracted from 360. Beautiful approach. Any other comments, questions, any concerns? All right. So the title of today's lesson had been hidden for a while because I couldn't quite fit everything on the page. Today is 11.1. Make sure you titled the lesson 11.1. And we're going to pause here to... So as I already explained, today's lesson 11.1, we are not doing a review day. We're not doing a test. We are in marathon mode till the EOC. So we're going straight into chapter 11. I do not have a cheat sheet for you yet. I'm pretty sure I'm going to give you one, but we need to talk about cheat sheet briefly. It's a good news, bad news situation, as I've said to you over and over again. And I guess my message didn't quite get across. Maybe I didn't say it right, and I apologize for that. So the good news about it is that I've condensed everything onto one piece of paper, or in some cases it took me 2 pieces of paper. It's a quick reference. It's easy to pull out. You can look at it. You can see everything. I've saved you tons of time writing. The bad news is that if you don't at some point put it away, you never learn anything. Or I'm sorry, you learn, but you don't retain. And as I talked to you last year about nobody wants to go to the doctor that has to Google everything, that doctor would never make it through medical school anyway, but let's pretend somehow they did. You would never go to a doctor and give them your symptoms, and then they would say, hold on a second. And then they would go Google, oh, that person's got a headache and a fever. Let me check what that means. No one would go to that doctor. That would be awful.
Sorry.
Not only that.
Okay, sorry, thank you.
Not only that, if they did Google it, it wouldn't lead to anything. Because it's the knowledge plus the experience that allows you to be creative and to solve problems. So if you didn't have these ideas in your mind, you had no chance of working through the problem. And as you saw, for example, in number 1 in the warm-up, it required 2 different ideas. And if you didn't have both ideas in your head, you wouldn't have been able to see that there was a connection going on. So if I give you a cheat sheet for chapter 11, use it. But at some point while you're doing the homework, or at some point during class, put it away without me telling you to. Because if you don't, then you're becoming the doctor who doesn't know anything. And that's what we're trying to avoid. That's not what I'm trying to support. Okay? Anyone have any questions about that? So nobody did anything wrong. Nobody did anything horrible. But I think I pretty clearly illustrated the flaw. That during the warm-up, many of you sat there for a long time and had no idea what to do. And that shouldn't have been the case. So let's move forward and let's improve ourselves. So, 11.1, we're going to start exploring circumference and arc length. You were introduced to these ideas yesterday during a short exploration. So first, we're going to be able to, by the end of today, find arc lengths. You're actually going to be able to find other measurements and circumference. And the only new vocabulary is the term arc length, which I introduced actually yesterday. So, do not copy. This is not copy notes. This is skim, read, discuss, and just understand, because you're going to know this so well, even just within a day, that it's not something you need to refer back to. Yesterday I introduced the concept of arc length versus arc measure. And it's interesting, as I thought about it, that if you and I were having a casual conversation and I just said, hey, what's the measurement of that? And you said, oh, its length is 10 feet. Well, I wouldn't be like, hey, you can't use the word length, you should have used the word measure. In a casual conversation, I would never distinguish between the words length and measure. to me, they would be synonymous. They would mean the same thing. But now we're seeing that not only can they not be interchanged, they have very different meaning. Arc length is one thing, arc measure is another. You already know arc measure. Arc measure is the measure of degrees. It's an angle measurement. It's basically the relationship of the arc to the degrees in a circle. Arc length is a linear distance. I know it's not linear because it's not a line, but we refer to linear distance in terms of inches, feet, meters, centimeters, and linear units. Okay? So you can distinguish between the two, but based on their units of measurement. An arc measure is going to be measured in degrees. And arc length is measured in linear units. And as I said, you will have this distinction down pretty well by the end of today. But, does anyone have any questions or comments about that? Or any concerns? Oh, and the cute little way of remembering it is the idea of the bug crawling. And so let me go to that. So the important piece is the piece that you guys discovered during your exploration yesterday, is that there's a relationship between the arc length and the arc measure. And we're going to make that more formal today. It's all based on circumference, though, so let's talk quickly about circumference. And actually, the first example we do is going to be about circumference, just to make sure we're clear on it. Circumference is the distance around the circle. It's the distance that a bug would have to crawl, crawling around the circle and always staying on the circle until they got back to the beginning. Mathematically, or formula speaking, it's c equals pi times diameter, or you could say 2 times r times pi. It's the same thing. So we can calculate circumference if we have the diameter or the radius. Any questions about circumference? So once we have that idea, then we can understand the next idea, which is the arc length is a portion of the circumference. So if a bug had to crawl all the way around the circle from point A all the way back to point A, that would be the circumference. If the bug crawled and stopped at point B, the bug crawled part of the way. Doesn't that make logical sense? So an arc length represents the portion of the circumference. Any questions about that?
I know in a 3D sphere, the circumference is the whole thing, but in 2D, wouldn't the circumference just be 360?
No, because now you're talking about degrees.
Oh, yeah, never mind.
So, right, so that's degrees. The number of degrees in a circle, we're talking about distance. And so if you have circles of different size, and so this is a good point that you're bringing up. If I have this circle, and this circle, all three circles measure 360 degrees, but their circumferences are dramatically different. Because walking around this circle is short, walking around that circle would take you a longer amount of time, right? If you were walking at the same rate. So that's the difference. Does that make sense?
Yeah.
Good. So now the idea we learned yesterday, it actually has a name. It's the arc length corollary. In a circle, the ratio of the length of an arc to its circumference is going to equal the ratio of the measure of the arc to 360. This is what you guys explored yesterday. This relationship can be used to solve a lot of problems. Since I do not have a cheat sheet, this is something you're going to need to have written down because this is a tool that we are adding to your toolbox that's going to be used over and over and over again. So I'm going to give you a moment just to make sure you have the proportion down so that we can utilize this over and over again. Right.
arc AB, but like when you just write it shorthand, what zero would we use because it ends with
Yeah, so someone else asked me the same question. I have not come across any short way of writing it. So I have been writing the word length.
you just like the cursive L.
I don't think so because I think the cursive L refers to line, but I'm not sure. So for today, we're going to write the word length. Not a big deal. I will do more investigating and see if there is a short way to do it, and I'll get back to you next time I see you. Is that fair? Okay. Now, let me take this one step further, and I introduced this thought yesterday as well. When you take the measure of an arc and put it over 360, you're actually figuring out a percent of the circle that that arc represents. And as you learned over your lifetime, especially over the last 3 years or so, you can use percents to do a lot of different things. So for example, if I said 90 degrees, if I just said, okay, a 90-degree arc, 90 over 360 is 25%, or 0.25. So that's saying that a 90-degree arc represents 25% of the circumference of the circle. So if I now said that the circumference was 100, and I'm making this up off the top of my head, if the arc measure was 90 degrees and the circumference was 100, what would the arc length have to be? If I had a circle and the arc measure was 90 degrees that I had marked off, and the total circumference was 100, what would the arc length have to be? Funk? 25. How'd you figure that out? Okay. Well, what did she actually do, Dalton? Right. But how can we use 25% to do it? Times what? Yeah, it's 25% of 100. So there's a connection between the arc measure and the arc length. And that's what we're going to be exploring in depth today. Anyone have any questions about that? Okay? So, example 1. I do not want you to write the text of the question. I want you to read the question. And I want you to quickly sketch the picture. Just a quick sketch. Nothing overly detailed. A circle with a measurement to help us. So, the question is, how far does a tire travel when it makes 15 revolutions? Let's talk about that word revolution briefly. So here in my hand, I have my pretend tire. And this is actually really helpful because of the 2 different colors. So I'm going to have to put this down here so hopefully you can see at least a little bit. A revolution will be going from red, rolling until I get to red again. So 1 revolution would be that. So how far would we cover if I just did that 1 time? What would that distance, so now we're talking about, let's pretend this. Let's pretend that I put ink around the edge of the circle, and I pressed it down, and then I rolled it, so that when I rolled it, the ink got pushed onto the surface. and then we measured the ink. What would that measurement be the same as? Jada?
It would be 4 times 1 side.
Okay, well this doesn't have sides, so I know it's supposed to be round.
Yeah. One face of it.
Okay, but we're pretending it's a perfect circle.
But when you roll it, it's going to be 4 times.
Okay, well you're getting stuck on the 4 times, and I apologize for that. That's where you got stuck. You're going to kick yourself when you hear it. Alicia?
Oh, the circumference.
What do you mean the length of the tire? The circumference, exactly. It's the circumference of the circle. So to figure out how far a tire will travel, we need to know its circumference. So we actually need to know, and I'm going to have to fudge this a little bit, do the best I can. We need to know this distance around the circle. That will give us 1 revolution. So, go ahead and do that. So the circumference of a circle is pi times d. We have the diameter of this circle, this tire. Give me a thumbs up if you can tell me the diameter of the circle. So I got a few people who can do it. Sebastian, what is it?
26.
Yeah, it's 26. How'd you do that?
Add all the measurements that they give me.
Yeah. Add up those measurements, you get the diameter of the circle. So the circumference is going to be pi times 26. So now we need our calculators, and everyone should have one of the scientific calculators from me. And your calculator is better than mine. So you're going to push the pi button and multiply it by 26, or reverse that, either way. I can't even do that. I don't have the pi button there, so I have to go to one of the same ones you're using. And so what do we get for the circumference of this tire? What do we get for the circumference? Got 5 people who got it? Go ahead, Sebastian, you're on a roll.
Around 81.68.
Yeah. So the circumference is going to be about 81.68, and we're in inches. So that's 81.68 inches. I know it's a round object, but that's a linear distance. But we were not asked for the circumference of the circle. We were asked for how far is it when it makes 15 revolutions. So what do we need to do now? Brandon? Multiply it by 15. Because now the tire is revolving 15 times. So go ahead, you've already got it in your calculator, it times 15. What do you end up with, Alicia? 1,225.22 or 0.2, somewhere approximately there. Any questions on how we did that?
I'm still not entirely sure on the revolutions. Is it like the planet when it comes back and it has to orbit around until it comes back to its original spot?
I get confused of what scientists use. I know there's a differentiation between rotate and revolve. And I get confused. So based on this, revolve to me is the object spinning on its own axis, and rotate would be spinning around another object. But for some reason I'm thinking that the scientists who study space do it the opposite. But I'm not sure. So I'll look it up for you. But for the purposes of this question, revolution meant the tire going from this point right here, rolling on the ground until that point ended up in the exact same spot. Okay? Good. Dalton?
Wouldn't you divide that answer by 2 because it seems linear?
Why would we do that?
Because it says linear.
Oh, yeah. Yeah, we should do that. Yeah, absolutely. It says to the nearest foot. So if you left it as that answer, then you unfortunately would get the whole thing wrong. because that is in inches, as I heard someone remind us. And so we need to divide that answer by 12, and luckily it's still sitting in your calculator. And we will get approximately how many feet? Go ahead, Dalton, you were the one who discovered it. Yeah, but if you put that, you get it wrong too. It's approximately 102 feet because it says to the nearest foot, which means the nearest whole foot. Anyone have any concerns about circumference? Concerns about circumference? Okay, so that was just the groundwork. So now let's build from there. And let's talk about the concept from today, really, which is being able to find arc lengths and other measurements of circles. So what we discovered yesterday and what we formalized today was that there's a connection between the arc measure and the arc length. There's a connection there. Since this is a central angle, the measure of arc AB will be 60 degrees. So if we say that 60 degrees out of 360, we know that this arc represents 1/6 of the circle. So we can use that. But technically, that is going to be equal to the length of the arc. So the length of arc AB out of the circumference. Now, I don't have the circumference here, but since we have the radius, we can easily calculate it. And again, with our powerful calculator, we can do that quite quickly. The circumference is going to be the diameter times pi. Diameter is 2 radiuses. So double the radius, get 12, multiply times pi. Round to something appropriate. So we get approximately 37.7 centimeters. So now, to find the length of arc AB, we have a proportion. Solve the proportion. I would not use 60 over 360. I would use 1/6. So I can easily do 1 times 37.7 divided by 6. So what do we get for the length of arc AB after all of that? What do we get? Got 2 people who got it? Am I going too quickly? 3 people got it? Okay, Sebastian, we're back to you. What do you get? Yeah, you get about 6.28, 6.3. That's fine. You get approximately 6.28 centimeters. That is the length of the arc. Remember, the measure of the arc is 60 degrees. The length of the arc as the bug crawls. Any questions on how we did that? All right, so let's do piece by piece for part B. So using what you've learned in part A and what you see in part B, I want you to set up something. Don't solve it, just set it up. And then let's come back together. So about 30 seconds. Yeah. Okay, so what did you set up? What were you able to set up based on the relationships you've learned today? Start with Michaela, and then Brian will either confirm or dispute.
150 over 360 equals the length of AB over 113.1.
Equals the length of arc AB over what?
113.
113.1. Brian, do you agree or disagree? Exactly the same thing? Anyone disagree? Chris?
5 over 12 equals x over, well, I used x instead.
Very good. So this can be simplified absolutely. So you could do 5 over 12 equals x over 113.1. And that certainly looks a little less intimidating than the first one, but neither of them are complicated. Good. Any questions about how we set that up? We calculated the circumference by using the radius. The circumference of the circle is going to be pi times the diameter. The diameter is going to be all the way across, so it's 2 of those. Yes or no? Yep. So then this circumference will be pi times 36, and that's how we got that right there. Okay? Good. I'm glad you asked. Good. So go ahead and finish it out. Give me a thumbs up when you've got the length of the arc. Length of the arc. I've got 1, 2, 3, 4, 5, 6, 7. Good. Put your thumbs down. Kayla, what'd you get for the measure of the arc? 47.12. Where are my thumbs up, people? I lost track of them. Alicia, do you agree? You put what? Okay. Well, I'm not sure exactly what it comes out to. Is 47.12 do we agree on? 47.13? What?
She rounded. It's 1 to those 5.
Oh, okay. So it's 47. Well, it kind of depends on how you rounded along the way. So it's possible that if you rounded this differently, then maybe it would come out different. So I can accept and deal with quite a few different answers. But it's going to be somewhere near 47.1. Very good.
When we have to answer a question like this on like a test, do we do the first 2 or the first 1 or the first 5 like we do this? Like the first 5 decimal places.
Oh, no, I would tell you what you would need to do. But usually hundredths is appropriate. Kind of depends on what the end result is, what you're looking for.
Just a question, but let's say we accidentally put the measure instead of the length on a test. Would you mark it wrong even if we had the right answer?
Well, how could it be the right answer?
No, like we wrote measure, but we knew that it was length. Like
Oh.
we put measure mark instead of length.
Oh, I don't think I would mark that wrong. I don't think I would worry about that. All right. Any other questions? Good. Prove it. If you're done before the bell rings, compare your answer to your teammates to see if you agree on what it should be. One second.
rounded from the middle, then you rounded in the boxes. And just put 34.95.
I just did it.
No matter how big. All right, I like the way I hear my students comparing their answers with their teammates, but let's see how we did. What is the length of arc AB? I've got students 20, 16, and 19. Student number 20. What is it? Okay, student number 16.
34.94.
Student 19. Not here. Student 17. Okay, so I'll accept anything anywhere near 34.94 centimeters. You put 34.9, 35, anything close to 35 centimeters will be acceptable. Give me a thumbs up if you got it right. Good, put your thumbs down. So that means we can now move forward to more complex scenarios because that was the basics. This same relationship can be used to find other things. For example, if we had the arc measure and the arc length, we could find the circumference. So in part A, find the circumference of circle Q. We have the arc measure because this arc's measure will be the same as its central angle, and we have the arc length. That's the part as the bug crawls. Yes? Go ahead, say it. 85 over 360, because that's the portion of the circle that's taken up by that angle, is going to equal what, Dalton? 12 over, and just in this case, I'm going to use a C because we use capital C for circumference, and so that's convenient. If you put an X, it's not a big deal. And so with some quick, simple calculations, we can actually find the circumference of this circle. Not too complicated, as long as you understand the relationship that's going on. So 12 times 360 divided by 85. What do you get as the circumference of circle Q? Just two people were able to get it using a calculator. Go ahead, Brian, what'd you get?
We got the circumference is approximately
50.82. I don't have the answer in front of me. Anyone disagree or agree? 50. 50.8, 50.82. Okay, so we got the circumference is equal to 50.82, and even though it's a circumference, we're still talking about linear measurement. So this is centimeters. Anyone have any questions on how we did that? Any concerns? So let's up the complexity a little bit further. In part B, find the radius of circle Q, and this is a different circle. Find the radius. And again, we have the arc measure, which is the same as the central angle, and we have the arc length. Well, we now know how to find the circumference. And we know that there's a relationship, some connection between the radius and the circumference. So let's work on circumference first. We already know what to do. Can someone set it up for us? What are we going to set up? Go ahead, Jada.
132 over 360 equals 14.2 over x.
Very good. So same idea, we'll get the circumference again. So nothing complicated, no incredible amount of thought involved here. calculator work, we can do 360 times 14.2 divided by 132, and we get a circumference of approximately 38.73. So we get the circumference of approximately 38.73. Is that right? 38.73? 38.73. And that is inches. But that's not what we were asked for. We were asked for the radius. So how could we go from circumference to radius? I want to be able to say radius equals something. What can we do, Shelby? Divided by pi, absolutely. And what else do we have to do after we divide it by pi? Catalina? That's right. If we divide it by only pi, then we will get the diameter. If we then divide the diameter by 2, we get the radius. So I have to use one of your calculators as well for this, so I can't project it. But you can go ahead and do that. We'll work simultaneously. So what do you get? What do you get, Brandon?
6.16 inches.
You get approximately 6.16 inches. Anyone have any questions on how we did that? Alicia? That's fine, but hundredths is pretty standard. So stick with hundredths if you can. So I'm handing you something, team leaders, if you could hand out. This is for you to use the rest of today. So you can write on it. So, checkpoint. Checkpoint number 2. Checkpoint number 2, find the perimeter of the shaded region. This is an independent activity. This is not a team challenge. Independent. You've got 4 minutes for this. It doesn't mean you can't talk. It means the goal is for you to be able to do this independently. If you want to discuss it with someone, go right ahead. Don't hesitate, but you should be trying yourself. Of course, if you need some guidance or some help, please let me know. You have the picture in front of you. not sure. I don't know if this is allowed here. I'm not sure. Okay, first let me make sure I've given everyone an appropriate opportunity. Give me a thumbs up if you have an answer, any answer at all. Okay, put your thumbs down. Okay, I'm going to ask for 30 seconds of patience by my students who have finished, and then I'm going to put the bars of equity into effect. So I'm just giving everyone a quick chance. I see a few people trying to finish up. All right. So now I feel like most people have been given the appropriate opportunity. So let's see how we did. I've got student 14, 3, 1, 5, and 7. Student number 14, what'd you get?
Oh, 28.
Student number 3. Student number 1.
34.84.
Student number 5.
32. Wait. I think 31.7.
Student number 7.
24.
So I got a lot of different answers. Correct answer is.
Oh my God!
So what you had to recognize was that, let's see if I can do this. It's going to be approximate, but this is a circle right here. Let me see if I can. This is really a circle. That's really a circle right there, except it's not the whole circumference of the circle. It's just this arc. So you had to figure out the distance from here on the circle to here. But the circle wasn't there, so you either had to imagine it or you had to draw it in. And that's why I gave you the diagram. And so putting the pieces all together, if you draw this up and draw this over, and you get, not quite perfectly, but what you get is the radius of that circle. And again, it's not perfect, but so now you had to do a little analysis with these numbers over here, and then you figure out that the radius of this is 2. Because this total distance from here to here is 6, and these are equivalent, so they must be 2 each. So the circumference of this circle is going to be 4 times pi. But we're only using 1/4 of it. So one arc, this arc right here, actually has a length of pi. That distance is pi, so is that distance, and that distance. So you have 4 times pi, but then you had to add all the straight distances. So you had a 6 over here, a 6 over here, and a 2 over here, and a 2 over here. And once you translate pi into its decimal equivalent, multiply times 4, and then add on 6, 6, 2, and 2, you get 28.57. Jada, Catalina, Brian.
If I look back at it, you didn't have to like find x because you could have took the 12.6 the circumference because it was like around the same radius times the same length of the arc times 4.
That's right.
So
So what you could have seen if you were able to is that if you took this arc and were able to pull it off and put it up here, and then take this arc and pull it off and put it over here, and take this arc and pull it off and put it over here, you'd end up with just one circle. So these distances altogether represent just one circle, and that was a great thing that you figured out. Catalina and then Brian.
I did all the math. I think I did it correctly, but the thing that I messed up on was I saw the circles, right, but I drew a dotted line for the radius, and then I found out that the radius was 2, and I drew it next to one of like the lines, and so it looked like 12, and I did 12, and I freaking
Okay. Well, that's an innocent mistake, and so, I mean, I appreciate you sharing. That's an innocent mistake that you can easily fix next time, okay? Brian. Good. Any other comments, questions? Okay, now, team challenge. So, I also gave you this diagram, but I didn't give you the question. Here's the question. How much farther does the runner on the blue track run compared to the runner on the red track? How much farther does the runner on the blue track run compared to the runner on the red track? That's really the question. The rest is contained within the diagram. So I'll leave my screen like this, but you also have the diagram in front of you. This time it is a team challenge. We don't have as much time as I would have liked. Oops, excuse me. So we'll put about 7 minutes on the clock to let you wrestle with this a little bit. And of course, if you need guidance, help, explanation, please let me know.
read the question once.
You don't need it. That's how much farther does the runner on the blue track run compared to the runner on the red track. The rest of the text just basically restates what's in the picture. Doesn't tell you anything new. Yes, Michaela.
When it says that 44.02, what is that talking about?
That is the radius of the semicircle. So if we drew a straight line, and you can do this yourself. Actually, you do it. You figure it out. I didn't want to tell you.
What it was.
You gotta interpret, figure things out. Okay, we're back as a whole group. I do not have as much time to spend on this as I would like, so let's just at the very least get answers. What did you get as the difference or the amount of meters that the blue runner had to run more? So we got lots of different answers. We'll start with Daniela, and then Chris, and then Jada, and then Davis. Okay?
45.36 meters.
Okay?
45.36.
Okay, Davis?
45.4 meters.
Okay, so seem to be an agreement between 4 people. It's approximately 45 meters. Anywhere around 45 meters would be acceptable. Give me a thumbs up if you and your team were able to figure this out. Got 1, 2, 3, 4, 5, 6. Good. Put your thumbs down. So, seems like we did quite well with that, and I'm proud of you for your efforts. So, your homework is page 714, numbers 8 through 28, and number 36 and 37. Your time will be most spent on 36 and 37. One of those asks you to draw a picture. Use the loaner compass that I gave you to help you draw the picture. Do the at-home tutor for 11.2 or read the next section.